Welcome to this online lecture on some philosophical issues in propositional logic. So this is intended for my Philosophy 112 course at LaGuardia Community College entitled Logic and Philosophy. And so in class we've been doing a lot of truth tables and trying to understand truth functional logic. So in this online lecture I want to step back and just talk about some of the philosophical themes that come out of this, some of the philosophical questions we might stop and wonder about. So to begin with, we want to start off with the truth conditions for material implication. So I don't have an arrow or a horseshoe on my computer that I could find in Keynote. So here I just have an arrow. So that's P horseshoe Q up there. And then we have our building up our truth table. And so as we know, this thing has the following truth condition. It's only false when the antecedent is true and the consequent is false, and it's true in all other cases. Now the first two are usually somewhat accepted, and it's the last two which strike people as a bit odd. And that's because, for instance, if you consider the following sentence, if I am a murderer, then I am a great teacher. Well, there it looks like you have a case where the antecedent is false. I'm not actually a murderer. And let's just assume for argument's sake that I am a great teacher. Well, so it's common sense would say, well, that sentence is false. If you're a murderer, that doesn't make you a great teacher. But according to truth functional logic, when interpreted truth functionally, that sentence is true. The antecedent is false, the consequent is true, the overall sentence is true. Well, that's very strange. Consider another example. So this sentence says, if I am 20 feet tall, then I am invincible. Now here again, I'm not 20 feet tall, so the antecedent is false. And I am very vincible, I will assure you, so the consequent in this case is clearly false. And of course that sentence just strikes me as intuitively being false. If I'm 20 feet tall, then I'm invincible. That doesn't seem true at all. But truth functional logic says that that sentence is true. So oftentimes students wonder, well, why is it then that we say that those sentences are true? And often in textbooks and in classes, you'll find a certain kind of defense where they'll try to point to some kinds of cases where it does come out that way. One striking case that I think makes it clear is the sentence, if it's a square, then it has four sides. And you may say that someone may be asking you about a shape that is out of sight. You can't see it. And you could say, well, if it's a square, then it has four sides. And then suppose it turns out that it's not a square, so it's false that it's a square. You still say, oh, that sentence is true, that if it's a square, it has four sides. So if it turns out that it actually isn't a square, it's still true. And also, if it turns out that if it's not a square and it also doesn't have four sides, so one case you find out it's not a square, but it's just some kind of rectangle. In another case you find out it's a triangle. So then you have both the antecedent and the consequent false. And yet it still seems like the sentence is true. So I think that works for some kinds of conditionals like the ones I just mentioned. But it doesn't work for like the ones that we have up here that we're looking at right now. Those ones just don't seem to be captured. So I think a better line of argument comes from thinking about the way valid argument forms work. So I want to go ahead and try to give you what I think is the best argument that if you're going to have an if-then statement in truth functional logic, it's got to have these truth values. So let's go ahead and start by thinking about modus ponens. Modus ponens is a valid argument form, and we can intuitively see that it's valid. So we want to preserve that, and we want, if our logic is going to be truth functional, then we want to make sure that it's impossible for this argument that has false premises. We want to make sure that it's impossible for this argument to have a false conclusion while also having true premises. So if we go ahead and consider that possibility, let's say what would happen if we made the conclusion of this argument false, and we also wanted to make this premise here true. So if Q is false, then we know that Q is false there as well. And if P is true, then we know that P is true in the first premise as well. So then the first premise has this line of the truth table, and if it were actually to turn out to be true in that case, then we would have a counterexample to modus ponens, and modus ponens would not be a valid argument form. So in order to make sure that modus ponens is a valid argument form, that has to have the truth value false. Now I think that intuitively makes sense. If the antecedent of the conditional is true and the consequent is false, then we intuitively judge the overall sentence to be false. So I think that this gives us some support for the following method. And we can make the same kind of point about modus tollens as well. So this is also intuitively a valid argument form. We can see that beforehand. So we could sort of come to the table accepting already that modus ponens is a valid argument form, because we can't think of counterexamples. We don't see how it could be the case that the two premises could be true and the conclusion nonetheless be false. And the same with modus tollens. Intuitively, if it's the case that if P then Q, and you don't have Q, then you know that you don't have P, because if you did have P, then you would get Q. That's what the first premise tells you. So you know that by not having Q, together with knowing that the first premise is true, you know that you don't have P. So that pattern of reasoning is valid in the sense of it can't have false premises and true, false conclusion and true premises. Why do I say that the other way every time? So let's go ahead again, consider what would happen if we made the conclusion of this argument false and this premise true. So once again, if we know the truth value of these things, then we know the truth value of them up there. So we know that if not P is false, it's false that not P, then we know that P is true. And we know if it's true that not Q, then we know that Q is false. So once again, we see that unless the truth value for this combination is as given in the second line there, we'll have a counterexample to modus ponens. So in order to preserve modus ponens as a valid argument, we need to assign the truth value false to this combination. So this style of argument, I think, demonstrates the need for these various truth values. So let's go ahead and look at the argument, which is going to be similar to the one I gave before, but the difference is that the one I gave before, I think, matches our intuitive judgments. Where this one, now we've seen that that works though, so let's move down here and give the same style of argument, and I think it'll be more convincing because of that. So consider the following kind of argument, which is called asserting the consequent, which is an invalid argument, and it sort of resembles modus ponens to introductory students, and that's, it says if P then Q, Q therefore P. Now this argument, unlike modus ponens, is invalid, and it's very easy to see that it's invalid if we think of the following counterexample. So if I am in New York City, then I am in New York State, if P then Q. I am in New York State, so I'm asserting Q. Therefore, I am in New York City. So now we can see that that's a counterexample because it can be true, it is true that if you're in New York City, then you are in New York State. That's true. And it could be true that I am in New York State if I was upstate, like in New Paltz, say. And yet it would be false that I'm in New York City. So we can see that this is an invalid argument. So we know that it's got to be possible to make the premises of this argument both true and the conclusion false. That's what I just did in the counterexample over here. So we know that the conclusion has to be false, and we know that if it's false there, then we put it false above. But we know that both of the premises have to be true in order for it to be a counterexample. So we can assign the truth value to the second premise here, to Q, and then we get the following pattern for the first premise, where the antecedent is false and the consequent is true. So now, suppose that you wanted to have a logic where you assigned false to that combination. Well, then you wouldn't have the ability to formulate a counterexample to this kind of argument. You would never be able to formulate an argument where the two premises were true and the conclusion was false. Because when that combination appeared, it would make the first premise false. But we know intuitively that we can formulate a counterexample where the premises are true and the conclusion is false. I have one over there, right there on the screen right there. So the only truth value that we can assign to that combination where the antecedent is false is the value true. That's all that we can do if we want to preserve this idea that this is an invalid argument. Now the same is true for the argument which kind of looks like modus tollens but isn't, and that's the denying the antecedent argument form. So you can run through the same steps and verify for yourself that if the conclusion is false and the second premise is true, then the pattern that you get above is false true. So that establishes, I think, the third line of the truth table and leaves open the question. Now, what about the last line of the truth table where you have false and false? Well, once again, we can consider an argument form. So here's one. If P, then Q, not P, therefore Q. Now that already looks like a bad form of reasoning, but we can again demonstrate so by forming a counterexample. So this says, if I am in New York City, then I am in New York State. I am not in New York City, so I am in New York State. So it's clear that my not being in New York City doesn't make me be in New York State. I could be in California, for instance, and be nowhere near the state. So that's clearly a case where we have true, true, and false. Now again, just as before, when we make the conclusion false here, and we make, so that means that it's going to be false up there in the antecedent, and the premises both have to be true in this case in order to make the counterexample. So when we make, sorry, I got ahead of myself in the animation. When we make that premise true, when we make not P true, then we assign F to the antecedents, and then the conclusion is false in this case, and so we get the pair that we've been looking for, false, false. Now, if we don't assign the truth value true there, then we don't have a counterexample to this weird, obviously invalid argument form. So the only option that we have, if we want to preserve our intuitive judgment about which of these argument forms are the valid ones and which of these argument forms are the invalid ones, then the only option that we have there is to assign it true. And we can do the same thing over here, and I won't go through it. I'll leave it as an exercise if you want. So what we start with then is an intuitive assessment of which of these argument patterns are valid and which aren't, and then we must make sure that our logical theory captures those intuitive assessments. Now you might wonder, well, what happens if you meet someone who denies that modus ponens is valid, and someone who thinks that maybe asserting the consequent is valid instead? And this is a hard problem because there's if someone denies that modus ponens is valid, they just, you think intuitively modus ponens is valid, and they think, no, it's not. It seems like it's invalid. It's totally possible to have true premises and a false conclusion. There's nothing that you could do to convince this person which wouldn't in some way rely on them accepting modus ponens. So this has been a puzzle in the foundations of logic, is how would you try to convince someone to accept certain logical rules as opposed to other logical rules? If they didn't accept those logical rules, then there would be no way that you could convince them, because you would always be saying, look, if you accept this, then you accept that, and look, you accept this, don't you? So you got to accept that, and they wouldn't recognize that as a valid argument. This is an interesting problem, and I guess I should have had more to say about it, but I'll just leave it at that, and maybe we can discuss it a bit more online. So what I wanted to do right now, though, is kind of draw out in a more formal way some of the consequences of what we just discovered. So this is what's sometimes called the paradox of material implication. And it can be summed up in these two formulae I have here. So the first one says, if P, then if Q, then P. And the second one says, if not P, then if P, then Q. So why are these surprising? Well, the first premise says, or these aren't premises, I'm sorry. The first statement there says that if P is true, then any proposition whatsoever entails P. So I'm 6 feet tall. That's true. So therefore, gold has atomic number 86. Therefore, I'm 6 feet tall. Well, that's right. Because if P is true, if the P is true, and it's in the antecedent position, then there's no way to make the conditional false. And we can check that this is a tautology. It's a theorem of logic if we run our truth table on it, just to double check this. So here we just put true, true, false, false for P, and then we alternate for Q, true, false, true, false, true, false. And then we rewrote the P column over there, true, true, false, false. If we compute the truth value for the conditional inside the parentheses, true, true is true, false, true is true, true, false is false, false, false is true. Then if we compute the truth value for the main operator there, that's true, true is true, true, true is true, false, false is true, false, true is true. And so we see that this sentence is a tautology. It's always true. It's impossible to make it false. But that seems a bit weird. Just because something is true, why should any random thing entail that thing? That's a weird thing. And the second thing is equally weird. If something is false, then that thing implies anything else. So if it's false that I'm 20 feet tall, then that implies anything that you like. And again, that's because if the antecedent is false, so if you say I'm 20 feet tall, and that's false, I'm not 20 feet tall, well, then you could put anything you like on the other end of that, and somehow that's implied. So this is a strange result, and we don't really know what to make of it. So some people think that, well, the material implication then leaves out or can't fully capture what's in English. And there are different schools of thought on this, and this is something that we can discuss online. But one school of thought was that, well, this is what the English word if then means. It just doesn't capture what people usually use that thing to mean. And so this brings up the difference between semantics and pragmatics, which was mentioned in a previous discussion that we had, which we could discuss here again. So some people think, look, these things are strange, but that's because it's a property of the formal system of language, which this accurately captures. But people use that formal system to communicate to other people things which aren't strictly part of the meaning. Whereas other people think, no, there's just a part of the meaning of the English words, which the logic doesn't capture. Okay, so that's some interesting philosophical issues that come up thinking about the truth table for if-then. And then, so before we leave, though, we can think about validity more generally. And I see I didn't have my animations on this slide timed correctly, so that'll make more sense in a second, unfortunately. So an argument is said to be valid when it's impossible for the premises to be true and the conclusion to be false. So consider the following argument. Suppose I told you I am speaking right now at this moment, and I am also not speaking right now at this moment. Therefore, I am the king of America. Now you might say, oh, wow, this guy, there's something wrong with him. I am speaking, I am not speaking, therefore I am the king of America. Well, we could formalize this argument. So I already had those things there. I should have had them come out right now, but I didn't time it right, and I'm not going to go back and redo it. So if we symbolize the first sentence as I am speaking as S, then I am not speaking as tilde S, and we can use K to stand for I am the king of America. So we could express this argument in the following notation. S and not S, therefore K. So that's a way of expressing the argument that I just gave you. I am speaking and I am not speaking, therefore I am the king of America. Now you say, that's suspicious, but it turns out that according to the definition of validity given above, this is a valid argument. The argument that I gave is completely valid. Why is that? Well, let's look at our sentence here. So we have S and not S implies K. So just doing our truth table on this, for S, we go true, true, false, false. For not S, false, false, true, true. And then for K, we alternate true, false, true, false. So in the interior in there, we're going to get all falses. It's S and not S. So according to the rule for conjunction, it's going to be false all the way down. But now notice, if the antecedent of the conditional is false, then the entire conditional is true. So there's no way that you can make the antecedents of this thing true and the conclusion false. You can't do it. That's because the antecedent is never true. So even when the consequent is false, the sentence is still true according to the truth functional rule. So this is sometimes what's called the paradox of entailment, that a contradiction implies everything. So you can say anything and you get an entailment to anything you want as long as you start with a contradiction in the premises. And that's supposed to be a very strange thing. Some people use this argument as a way to try to back up the idea that contradictions can't be true. So the problem here was that we thought we could assert this contradiction. And so maybe if you don't allow that, if you just don't allow contradictions to be asserted as premises in arguments, you just say they're not allowed by the system, then you don't get those results. And so when people say, well, look, if you allow a contradiction, then you get this explosion. It implies everything. Now, interestingly, there are systems that allow contradictions to be asserted or to be involved in arguments and that don't explode. And those are so-called many-valued logics or paraconsistent logics. And I think we'll have to make it up through the predicate logic if we're going to talk about any of that stuff. But it's something to look for on the horizon. For now, we can just see an interesting problem for an interesting philosophical problem for propositional logic.